In today's class, we will solve some of the viscosity problems. These problems are different compared to the last two previous classes viscosity problems. Take one by one. Here, two fixed plates are given. The first one. This space is filled with oil. The oil dynamic viscosity is given 0.8 Newton second per meter square. Here, at the equidistant means 1 centimeter from this plate and 1 centimeter from this plate, we are keeping one moving plate, thin plate. The area of this thin plate is 0.5 meters square. It is given, and the velocity of this plate is also given 0.5 meter per second. We are pushing this plate in this direction. What we have to find in it means how much force is required to push this plate for this velocity. For moving this velocity, how much force is required for this plate for pushing in this direction. So here in this problem, we have to find the force required to push the thin plate in this direction with the velocity u is equal to 0.5 meter per second. So how to solve this problem? Here we have one formula, shear stress formula, as we did in the last classes also. Here we have to find the shear force, find the force required. Okay, so here what is shear stress formula? Shear force by area. So tau is equal to mu into du by dy. Okay, this is the formula. In the last classes also we took this one, and here we need to find Fs. Okay, keep as it is Fs this side. Send this area here A into the remaining values are same as it is. Okay, here if you observe, this side also oil is there, this side of this plate, and this side of the plate is also oil is there. Okay, so one shear force here, one shear force this side. Okay, so here for total we have to add Fs1 plus Fs2. Fs1 is shear force on this surface, Fs2 is shear force on this surface. Okay, two shear forces will come. We have to take this formula. Okay, I am writing here Fs1 plus Fs2. So here what we are getting, A1 mu1 du1 by dy1 plus Fs2 means A2 mu2 du2 by dy2. So here these two are the formulas for Fs1, Fs2. Here we have to observe, we are taking the common plate. This plate is A1 is equal to A2. We are using the same oil this side and this side. Mu is 0.8. Mu1 is equal to mu2. Okay, and same plate we are taking, velocity is also same, du1 is equal to du2, and this dy means distance from fixed plate to moving plate. How much it is? It is given 1 centimeter. Here dy2 is distance from fixed plate to moving plate. How much it is? 1 centimeter. So dy1 is equal to dy2. So all quantities has same this side and this side. So we can take 2 into A into, or we can take A1. A1 is equal to A2, mu1 is equal to mu2, du1, du2 also same, and y1, y2 also same. 2A1 mu1 du1 by dy1. Okay, now substitute all the values, we will get total force. 2 into, what is the area of the plate? It is given, area of the plate is 0.5 meters square. Check the units, because we have to convert if it is given in centimeter. It is given in meter, so take as it is 0.5. Mu1 is given 0.8 Newton second per meter square into, what is velocity? It is given 0.5. Okay. So what is the distance between fixed plate to unmoving plate? 1 centimeter. So convert this in terms of meters. So 1 centimeter means I am taking 10 power minus 2. Like this. Now do with calci for finding the total force. Fs1 plus Fs2. Answer is total force Fs1 plus Fs2 is 40 newtons. So here this side Fs1, this side Fs2. Total force 40 Newton is required to drag the or push the plate with velocity 0.5 meter per second. So this is the solution. Now take the same question, second one in it. Here the difference is this plate is keeping nearer to one of the fixed plate. Previously it is equal distance from this plate and this plate, 1 centimeter, 1 centimeter. Here the same plate means same values. Oil is same, area of the plate is also same, and the velocity is also same. It is given 0.5 meter per second. Now here only thing difference is the distance from one of the plate is less compared to the distance on the other side. I am taking this is y1, this is y2. Okay, in it also we have to find the force, total force required for pushing this plate in this direction with velocity 0.5. So already I did the formula here, Fs1 plus Fs2. So take the same formula and write down the values. But in this case also A1 is equal to A2. How much area it is given? It is given 0.5 meters square. And what is mu value? Mu1 is equal to mu2 is equal to, it is also given 0.8 Newton second per meter square. Now find out the force Fs1 plus Fs2. First write the formula A1 mu1 du1 by dy1 plus A2 mu2 du2 by dy2. Okay. Now substitute all the values. A1, A2, mu1, mu2 all same. So I am taking common A1, mu1, and du1 also same because it is moving with same velocity. So here what we are getting, 1 by dy1 plus 1 by dy2. Now substitute all the values. What is area? 0.5. What is mu value? 0.8. What is velocity? 0.5. So what is dy1? It is 0.75 centimeter. I am taking in terms of meter. 0.75 into 10 power minus 2. So 10 power minus 2 here it will come. I am taking here 10 square by 0.75 plus 10 square by, what is dy2? 1.25 centimeter. So I am taking 1.25. By using calci we got 42.67 newtons. So if you are comparing this total force Fs1 plus Fs2, in this case more force compared to the previous force. Previous force is 40 newtons. When the plate is at the middle, it is moving in this direction. Here it is 42.67, around 2.67 newtons more in this case for pushing this plate in this direction. Take the next problem. It is very important problem for the competitive exams. Here two vertical plates are given. These are the fixed plates. These are 2 centimeters apart, and in it some oil is there. The oil density is given. Rho of oil is 900 kg per meter cube, and dynamic viscosity of this oil is 20 poise. So in it one thin plate is immersed at the middle of this gap. This thin plate dimensions are given, volume is given 1 meter by 1 meter into 0.2 centimeter. If you are taking the diagram in 3D form, 1 meter by 1 meter means it is a square plate, okay, and 0.2 centimeter thickness means this is the thickness. So in the problem he has given thin plate is immersed in this given oil. Thin means it is the 0.2 centimeter is the thin side of this given plate. So we have to keep like this at the middle of this gap. Okay, if you are removing from 2.2 centimeter, 2 minus 0.2 means it is 1.8 centimeter. Okay, this gap plus this gap is 1.8 centimeter. Half means 0.9 centimeters. So this gap is equal to 0.9 centimeter. This gap is 0.9 centimeters. Okay, so 0.9 plus 0.9 plus 0.2 means it is 2 centimeters. What is the other given data? The weight of the plate is 30 newtons. So the weight of this plate is 30 newtons. Now here I am taking the thickness of this plate is 0.2. Okay, and the weight is acting downward as we know because of gravitational force. And what is the other given data? Velocity of the plate is given 10 centimeter per second. Okay, this plate is moving in the upward direction, lifting this plate in upward direction with the velocity 10 centimeter per second. So what is the other given data? What we have to find? Find the force required during lifting of the plate 30 newtons. So lifting of the plate means we have to apply some force for lifting this. We have to find the force required for lifting this plate with the velocity 10 centimeter per second. Okay. Now here first we have to take what are the forces acting on this plate. Okay. We need to find the force for lifting this plate. Okay. Now if we do the diagram here separately, this is the plate. Okay. We need to find this force. For finding this force, we have to first consider what are the forces acting on this plate. First one is weight of the plate is 30 Newton. Weight is acting always in the downward direction. It is 30 newtons. And then it is surrounded by this oil. Okay. So because of it, shear force is developed. Okay. If the object is moving in this direction, shear force is in the downward direction. Okay. So it has two surfaces, this side and this side. So Fs1 this side is acting downward, and then this side is Fs2. Okay. Now here this is the same plate, and at the middle of this gap, so Fs1 is equal to Fs2 because oil is also same both sides and same dimension both sides. So we can take Fs1 is equal to Fs2. Now these are three forces are downward forces. And now I will tell one example. I have one measuring jar. In this measuring jar, some 2 meter cube, 4 meter cube marking is there. Okay, 8 meter cube, 10 like that. I am taking some volume initially. Let us take it is 6 meter cube volume. Okay. Now I want to find one object volume. Some A object of irregular shape is given. How to find the volume of this? By using the measuring jar. So first keep one thread here and keep in this liquid, whatever liquid is given. Okay. Initially before keeping in it, it is volume is 6 meter cube. Okay. Now after keeping this object inside this A object, it is coming, let us assume the level will increase. It is coming 8 meter cube. The volume now, liquid volume is 8 meter cube. So what is the difference between initial position and final position? V2 minus V1 is 2 meter cube. 8 minus 6, it is 2. So this 2 meter will indicate the volume of this A object. Okay. Similarly, if you are keeping this thin plate in the oil will displace. Okay. The level of oil will increase. So that liquid force, we can call it as buoyancy force. So it is in the upward direction. Now I am taking liquid force, whatever it is acting in the upward direction, because weight is acting downward, liquid force is acting in upward direction. It is called FB, buoyancy force. Okay, we have to find buoyancy force by using the displaced volume of the oil. Okay. So if you are taking what are the forces acting on this object, for finding the F, I am taking upward forces is equal to downward forces. Okay. So for the equilibrium of this object, we are considering whatever upward forces is equal to downward forces. What are the upward forces? We need to find the lifting force of this object or plate, F. What is the next upward force? Buoyancy force, FB, is equal to only two upward forces. What are the downward forces? Weight of this 30 newtons plus Fs1 plus Fs2. Both are in downward direction. As we know Fs1 is equal to Fs2, we can take 30 plus 2 into Fs1. Our main aim is we have to find F value. So here F is equal to, we can write 30 plus 2 Fs1 minus of Fb. Okay, so we have to consider this formula for finding the force required during lifting of the plate. Okay, here how to find FB, buoyancy force. Okay, so here how to find, so by using weight of the oil displaced. Okay, weight we are measuring in terms of newtons, that weight will give the buoyancy force. Now write down here FB is equal to weight of the oil displaced. Now how to find weight of the oil displaced? Is there any, we have to take force. Okay, weight of the oil displaced, because we are considering in this all forces in newtons. Okay, so weight we are taking W is equal to mg, like F is equal to ma, we are taking like that. So here instead of m we have to take the relation, because we know the volume of this, it is given volume of this plate. Okay, so we have to take in terms of rho and volume. We know density is equal to mass by volume. I am taking here. So by using this we got this. We have to consider this. Now in this formula we did this FB, buoyancy force, it is 17.65. We need to find shear force. Okay, so we have one formula for shear stress. I will write this side. Shear force by area is equal to mu into du by dy. Okay, now we need to find F. So the both sides fs1 fs2 both are same values. So fs is equal to, a will go this side, a into mu into du by dy. So it is also equal to fs1 is equal to fs2 is equal to this formula. Now what is area of this plate? If you are taking the cross sectional area 1 by 1, okay, it is the area. So 1 by 1 into what is dynamic viscosity of the oil? 20 poise means 1 poise is equal to 1 by 10 Newton second per meter square. Okay. Now mu of oil is equal to 20 by 10 means 2 Newton second per meter square. Okay. Always remember this relation. Now here we will get 2 Newton second per meter square mu value. So I am keeping 2 here into what is du value? Velocity is given 10 centimeter per second of the plate velocity. Okay, so I am taking 10. So in terms of 100 means in terms of meters means divided by 100. What is distance? Dy value. This is the distance between moving plate and fixed plate, 0.9 centimeters. So here we will get 0.9 centimeters means I am taking 100 here in meters. So this 100 will be cancelled. 100 will be cancelled. 2 into 10 means 20 by 0.9. I will get fs1 is equal to 22.2 newtons. Now substitute fs1 and fb values in this equation. We will get F, lifting force for the plate in upward direction. So from this equation 1, F is equal to 30 plus, first write the equation, after that substitute the values. 30 plus 2 into what is fsn value? 22.2 newtons minus what is the buoyancy force? 17.65. Now do with calci. 30 plus 44.4 minus 17.65. It is around 74.4 minus 17.65. It is coming 74.4, 17.65. It is approximately 56.74 newtons will come. Okay, so this is the lifting force for this plate in upward direction with the velocity 10 centimeter per second. Okay, so this is the procedure of this problem. So I give the viscosity video link in description box, please check it. Take the first question. In it, 1 meter square plate is moving on the surface, inclined surface. This inclined surface is making 60 degrees with the horizontal surface. Okay, it is moving down, it is given. So in between this surface and this plate, some oil is there. It has a oil surface, this inclined surface of 1 mm thickness. Okay, and then weight of this plate is given, it is 100 newtons, And oil dynamic viscosity, that is mu is given, it is 1 poise. Now here what we have to find means we have to find the velocity of the plate, that is u. So with how much velocity it is coming down. So here if the object is moving down, shear force or shear stress is acting opposite to the movement of the plate. Always remember, if any object is moving in this direction means, let us assume, okay, shear stress is always acting opposite to it. Okay, so similarly here this is moving in downward, it is given, it is sliding down, so shear force or shear stress is acting in this direction. I am taking Fs, or shear force I am taking, shear force is Fs. Now here we have to take, this is the vertical component 100 newtons, okay, and then it has two components because the surface is making 60 degrees. For this vertical force there are two components. One is parallel to the surface is angle, okay, like this, parallel to one surface, one component, and one component is perpendicular to the surface. One is parallel to the surface, one is perpendicular to the surface. Okay, so in engineering mechanics also, for inclined force we are taking two components. One is horizontal component, one is vertical. But here the horizontal, it is not the horizontal surface, it is making some angle. So parallel to the surface one component, perpendicular to the surface another component. Here we have to find the angle, how much angle it is making. This angle we have to find. How to find that angle? If you are taking, this is right angle triangle, okay, and this angle is given 60 and this angle is 90 degrees as we know. This angle is 180 minus these two sum, because in the triangle total sum of the angle is 180. Okay, I am taking 180 minus sum of given two angles, 60 plus 90. Okay, we will get this angle. So how much it is? 180 minus 90 means 90 minus 60 means 30 degrees. Okay, this angle is 30. Okay, now here how much this angle? It is also same, because parallel surface, it is a common vertical line. Whatever this angle is also same. It is 30 degrees. I will write here the angle is 30. Okay, so write with blue so that it is clearly visible, 30 degrees. Here before marking the components, I give one example. So take one example. In it, here I am taking one component. I am taking F, it is. Okay, this angle is some phi angle. Okay, now we need to find horizontal component, vertical component. Two components we have to find. What I am doing means I am doing just I am extending this. I am making into right angle triangle. This is the horizontal component. Let us take it is FH. This is the vertical component. We need to find these two values. For horizontal component, take cos phi. So FH by, what is this value? F. Okay, so FH is equal to F cos phi. Okay, this is the horizontal one. For finding vertical, take sin phi by using the right angle triangle, FV by F. Okay, so FV by F. FV is equal to F sin phi. Now mark these components in the given diagram. Instead of FH, I am taking F cos phi. Instead of vertical, I am taking F sin phi, as we got the values. Okay, so always remember, whatever angle line will be there, cos will come with this value F cos phi. With vertical component or perpendicular component, sin will come. Okay, so in the same way, the given two components are there, so the components will be like this. This is the W. It is making some 30 degrees. So with 30 degrees line, I am taking W cos 30 this side. With vertical, I am taking W sin 30. Similar to this diagram. Okay, here it is horizontal with angle is making with horizontal. Here we are taking the angle with the inclined surface. Wherever angle is coming, it is cos will come. So W cos 30. The other side is W sin 30. So mark here W cos 30 here and W sin 30 here. So write down W sine 30, here W cos 30. Now take Fs, whatever this value is equal to this value, because both are acting parallel to the surface. Okay. Now I am taking, this is upward, Fs is equal to W cos 30. Okay. What is W value? It is given 100 newtons. 100 cos 30. How much it is? 100 cos 30 means root 3 by 2. I think so. It is 50 root 3 newtons because it is a force. Now substitute this value in shear stress equation. We have one formula, tau is equal to mu into du by dy. We need to find u value. Okay. Now here substitute all the values. Shear stress is equal to shear force by area is equal to mu into du by dy. Okay. Now here what is du value? Here we have to find. What is Fs value? 50 root 3, just now we did 50 root 3. What is area? It is given 1 meter square. 1 I am taking. What is mu value? 1 poise. 1 poise is equal to, here Fs I took, just now we did 50 root 3 divided by area means it is given 1 meter square area of the plate. Okay. Now after that, what is mu value? Mu is given 1 poise. So always remember 1 poise is equal to 1 by 10 Newton second per meter square. Okay. So instead of 1 poise, take this value newtons, because we are taking this is also in newtons. Okay. Now I am taking 1 by 10. Du we need to find. What is the dy value? Thickness of the film thickness 1 mm. I am taking in meters 10 power minus 3. Okay. So in it, find out du or u. You will get du is equal to 50 into root 3 into 10 into 10 power minus 3. Okay. Do with calci. You will get the value by using calci. We got velocity is 0.87 meter per second. With this velocity, this plate is moving in downward direction. Here it is important to take always the value is Newton second per meter square, because we are taking forces in newtons.